Today we're going to be looking at the idea of using the Swift playgrounds to examine the changes that happen between Swift 2 and Swift 3. Now there's some major changes that have actually occurred in the language, and we can see right now just by looking at our level of loop right here, we can see some errors are really unhappy. This is obviously normally traditionally very good code using Swift 2, making an index, iterating up until 5, going up by 1 each time. Great little sequence right there. But Swift 3, however, has made some changes to that. So we're going to go ahead and take a look at the actual changes that were made so we can see what's going on and see some of that. The first thing we're going to notice is we're going to get an error right here on the plus plus operator. The plus plus increment operator, whether it's prefix or postfix notation, as well as the associated minus minus operator, have been removed from Swift 2. So if you hover over here on our lovely error right here, and we see the idea that the plus plus has been removed, it's unavailable. It's been removed in Swift 3. So we're going to go ahead and take that error right off. So we'll go ahead and we'll get rid of it and use the suggested fix of going to plus equals and 1. So it's just the same exact statement, index plus equals 1, still goes and adds 1 to it. However, the plus plus operator, like we said, no longer available. However, notice we still have a lovely error right here. We have the idea that the C-style for statement has also been removed. So there have been two major changes to the language that go for legacy code inside that. And so what we have to do is we have to actually make some changes to it. If we hover over this, as you can see right here, if I hover over that lovely structure, you can see there's a change that is suggested to replace that, where it's going to be some changes on there, where it's using the for in style of the loop. And so we're going to go ahead and take a look. We're just going to comment this out. And so go ahead and whack this out. And we're going to scroll down just a bit. And as you can see right here, we have an array of words. Now the for in statement we've used already with our existing loops right here. And as you can see right here, I've got the my oh my approach that's happening with that. So I have my words array right here, let words equal my oh my, and I'm printing out each of those words, my oh my, in order, using the implicit structure of that array. As it iterates over it iterates for each word in words. And notice again in Swift, we do not have to specify the type of the iteration variable. It implicitly iterates over the structure that is stored inside that. So in this case, for word in words, I simply call the print word. As you can see in the playground's environment, that executes 3 times. We look down here in our execution role, and we have my oh my printed out directly on that. We'll take a look at this next one right here. I have a function that returns a number. In this case, it's some number, returns a magic number of 7. Amazing function, as you can see. And I'm going to use the idea of a couple different sequences right here. And so we have the for in loop right here, where we have the idea of a for in index is 1.5, and print the number is index. In this case, we have right here, as we scroll up just a little bit further, we have the number is, and then 1, 2, 3, 4, and 5. And so that index is again implicitly defined for that range. And so the structure we have with the idea of the for in loop when we're using it as a iteration tool is we have the iteration variable that we're going to be using, the in keyword again, and then the range that we're going to be using for that. In this case, 1 through 5. And so automatically is going to be using that. With this case, it's automatically going to execute 1 at a time, going up 1, 2, 3, 4, 5, as you can clearly see right there, executing the associated statement of string interpolation right there. We also have the idea of using a function right here as one of the parameters of that range. In this case, I have the for index in 1 ... minus. Or as you can see, we also have the idea of using the method call right here, but we're using range. But instead of using the 3 dots in a row as I did here of 1 to 5, I'm using the ... less than symbol, which goes up to but not inclusive of the value returned by that method or variable. In this case, 1 up to but not including 7. So it's going to execute 6 times. Let's take a look and scroll down here just a bit. And notice again right here, print index again times 10, executes 6 times. We scroll down through this and we have 10 through 60 printed out right there. So the idea again is that we have the idea of a range, either with a range implicitly defined as a data structure with its iteration variable directly before the in keyword, or if we have the idea of a numeric range, we have the index and then the range that's specified, starting with its beginning inclusive value and ending either with an exclusive value denoted by the 3rd dot or an exclusive value denoted by the less than symbol. So we have the idea of using a Swift range for that. I'm going to go a little bit further with that. And so we have this lovely array right here. We're making an int array. We can add to the array just like we normally do, and I can append to the array. So stuff.append count. So I'm going to add to my array each time whatever is inside that iteration. And so that array executes 11 times. And I'll use that next statement right here. So I'm going to use the index in stuff.count. The value at the index is stuff subindex. And I scroll down right here, and we have the value indexes 0 down through and including 10 because it's an inclusive loop using that third dot. In this case, though, we use the 0 dot dot less than stuff dot count because we are only going to go up to each of those spots because I started off at 0. That gives us 11 times for this execution. For 0 less than stuff dot count, we have 11 times right here. There's 11 items in that, but we only want to go up to that index right there, and so we have it right there. We also have the ability to use what's called a stride method. And this stride method is the way we can actually go through and do some of the more advanced features of a regular for loop. It's implied now that we're going to use a defined range. This stride method creates a range that we'll be iterating over. We use 3 parameters in the stride method: the from, through, and by parameters. From is where we start off, through is the testing, at to which point do we end, and finally, how much do we change it by each time. In this case, I'm changing by 2. And so the value at index is stuff subindex. In this case, we can see we're going by evens: 0, 2, 4, 6, 8, and 10. So we have the idea that we're going to be able to go through that, getting evens only going forward. I also show the same thing going backwards with this next iteration. For index in stride from stuff.count minus 1, again, because we want to actually go for the regular index of a 0-based array, through 0 by -2, so it's going to go down by 2s, and as we can scroll down right here, we have 10, 8, 6, 4, 2, 0. So we have the idea that we can use the stride that goes through that, going through and accessing that right there. So again, just a quick little review as we look at that. The C-style loop is no longer available, not even if we use the plus equals approach, and especially not because we use the idea of the plus plus, since the plus plus operator has been removed from the Swift language. So this one right here, completely unavailable. We can't do that at all. And if we do want to change something by 1, we have the now standard approach of plus equals and 1. So for any incrementation, it's plus equals and the associated value are going to be changing by that. No longer will we be using the increment operator of plus plus or minus minus. Iteration for a data structure, simply give the variable and the variable structure we're working over, and we can iterate directly right over that. You can even implicitly define one right there and iterate through it in that fashion as well. You can pass methods for this for the creation of that range, or define the range numerically as in that. And again, we also have the ability to do more complex iteration by using the stride method. Again, the stride method takes 3 parameters of from, through, and by, allowing us to change the direction and the amount that we skip through the actual structure. And so we can do any complex information we need through that as well. There's some other enhancements to the for and loops we can look at another time, but thank you and have a great day.